All right. We're going to look at integration by recognition. So what that means is sometimes you need to differentiate a function, find the derivative, and then from that derivative, you need to recognize that that can help you find an antiderivative of something else. So let me explain what I mean. So the question sort of comes in two parts. So let's look at this. It says differentiate y equals x sine x, and hence find an antiderivative of x cos x. Okay, so when we differentiate x sine x, I reckon there's going to be something to do with x cos x in that derivative, and then we can make some recognitions and draw some conclusions from that. So let's just differentiate this first. So hopefully you realize that that's a product rule. So we've got the first function u, which is x, and the second function v, which is sine x. Okay, and then we've got the derivative of u with respect to x is 1, and the derivative of sine is cosine. Okay, and then you've got to apply the product rule. So u times dv dx multiplied by v times du dx. And that will give you this. This gives us the derivative of x sine x is x cos x plus sine x. Okay, and as we said, we can see that this derivative of this has x cos x in it, and what we're trying to find is an antiderivative of x cos x. So let's keep going. What we're going to do now is we're going to say, all right, if the derivative of x sine x is this, then an antiderivative of x cos x plus sine x must be x sine x. So that's what we need to set up. So we're saying an antiderivative of x cos x plus sine x dx must be x sine x. And then what we need to do is we need to isolate x cos x. So what we need to do is we need to break this integral up into two separate things. And so, yeah, we get the integral of x cos x dx plus the integral of sine x dx, just using our integral properties. The fact that the integral of a sum is the sum of the integrals. Okay, and then we're almost there. We just need to, as I said, we need to isolate this and we need to move everything else to the right-hand side. So if we integrate sine x, we get negative cos x. And that's, yeah, just one of our rules for the integral of sine x. And then we add that minus cosine x to the other side, and then we get this. We get x cos x dx equals x sine x plus cos x. So there we go. We have found an antiderivative of x cos x by using the derivative of x sine x. So the grand finale here, if we draw both of those graphs, we're going to get something like this. Looks pretty cool. And let's just talk about the graphs here for a second. I think they look pretty neat, but basically, obviously, an antiderivative of x cos x dx is this. So that must mean that a derivative of x sine x plus cos x is x cos x dx. And that should make sense. If we look at this green line and think about the derivative, well, we've got a point here, which would have a gradient of 0, and that corresponds to an x-intercept on the blue line. Similarly, here we've got a gradient of 0, and that would correspond again to an x-intercept on the blue line. Similarly here, gradient of 0 corresponds to that. So sometimes it's easier just to think in terms of the gradient of the function rather than thinking of an antiderivative. So yeah, we could say that the derivative of the green line is the blue line, or by the same logic, an antiderivative of the blue line is the green line. All right, hopefully that clarifies integration by recognition. Always comes in two parts. And yeah, you need to isolate the thing that you're looking to solve for.